Today we're going to talk about compound interest. Compound interest occurs when interest on an investment is reinvested in the account and thereby creates a new larger investment that will earn even more interest. In this scenario, you earn interest on both the initial amount you invested and any earned interest. James invests $8,000 at 10% interest for 2 years. If interest is compounded annually, how much will be in the account at the end of the 2-year period? So in year 1, we have the $8,000 that James started with plus 10% of the $8,000. This gives us $8,000 plus $800. So at the end of year 1, there's a balance of $8,800. In year 2, we have the $8,800 that we started with plus 10% of that amount. So now we have $8,800 plus $880, which is a total of $9,680. This means James earned the difference between $9,680 and the $8,000 he invested, which is $1,680. Let's look at the difference between compound interest and simple interest. So we just found that 2 years at 10% interest compounded annually gave James $9,680. If we were to compute simple interest instead, we would have A equals P times 1 plus RT. Our amount would be the $8,000 times 1 plus 10% for 2 years. This is a total of $9,600, which is a difference of $80. So let's look at a formula to make this easier. We have A equals P times 1 plus R over N to the NT. So just like before, A is the future amount, P is the present amount we invest, R is the interest rate that we're still going to write as a decimal, and T will be the time, and we always write time in years. The new thing here is N. N is the number of compoundings per year. So in the last example, we just did annually, but I'm going to show you other examples where the compoundings are more frequent. Some common compounding periods. So we already talked about annually, which would be 1 time a year. Semi-annual will be twice a year. Quarterly will be 4 times a year. Monthly will be 12 times a year. Weekly is 52 times a year. Daily, it's either 365 or 360. You really have to watch the wording of the problem. When I want it to be 360, when the homework wants it to be 360, it will tell you. Otherwise, use 365. How much money will you have in 3 years if you invest $5,000 at 6.5% interest compounded quarterly? Let's pull out our pieces of the formula. We can start with P is 5,000. That's how much we're going to invest. 6.5%, I just want to write as a decimal, so that's 0.065. Quarterly means it's 4 times a year, and then my time is 3 years. Let's bring back our formula, A equals P times 1 plus R over N to the NT, and let's plug our pieces into that formula. So you can see here I have A is 5,000 times 1 plus 0.065 over 4 to the 4 times 3. How you put this in your calculator is really dependent on your calculator. I find it really helpful to do this one simple step of 4 times 3 is 12 before you try to use your calculator to do the whole amount. You should be able to plug it in just like it looks right here. 5,000, make sure you use the parenthesis, 1 plus 0.065 over 4. Make sure you close the parenthesis and then use the exponent button with 12. This should arrive at $6,067.04. It's super important that as you're watching the video that you're trying this with your calculator. You need to see what buttons you're supposed to push, what order you're supposed to push them in, and the more times you do it, the better you're going to get at it. One more note, just in case I were to ask you, hey, how much interest did you earn? You always subtract the total amount you had, $6,067.04, from the amount you invested, $5,000, which means there's $1,067.04 in interest. Kara invests $32,000 in an account earning 2% interest compounded weekly. How much money will be in the account at the end of 4 years? So just like before, I'm going to start by saying my P is 32,000, my R is 0.02. This time weekly compounding means N is 52 and our time is 4. I plug this into my formula. So you can see I have 32,000, I have 1 plus 0.02 over 52, and then 52 times 4. So just like in the last problem, before I grab my calculator, I'm going to do 52 times 4 is 208 to arrive at $34,664.65. How much money should be invested in an account earning 3.75% interest compounded monthly in order to have $25,000 in 6 years? So this time, I don't know what P is, but I know the amount I want in the future is $25,000. I know the interest rate is 0.0375. Compounded monthly means N is 12. And the time is 6. All of that goes into our formula, but you can see this time what's missing is P. So just like I've done in all the other problems, I'm going to start with 12 times 6 is 72. To get P, I'm going to want to divide 25,000 by this whole amount that's in the parentheses. I try not to do any estimations or any rounding until the very end. So you can see I'm going to put this whole thing into my calculator. So I'll have 25,000 divided by parentheses 1 plus 0.0375 over 12, close parentheses to the 72. If you put this in your calculator before and you rounded it all, it's going to make it so much worse when you raise it to a power, round that again, and then divide. So the best thing to do is round at the very end and keep all the values as you go in your calculation. So this told me I would need to invest $19,969.91 in order to have $25,000 in 6 years. So example 5, say you deposit $7,000 in an account paying 4.2% interest compounded semi-annually. After 2 years, the interest rate is increased to 4.5% compounded monthly. What will be the value of the account after 5 years? So this problem is much different because it wasn't the same amount of interest and the same amount of compounding over the entire amount of the investment. So we're going to need to do this in multiple steps. Part 1, we need to figure out what's happening at 4.2% semi-annually. And then part 2, we need to figure out what will happen at 4.5% compounded monthly. So for part 1, we started with $7,000. The rate of interest was 4.2%. This lasts for 2 years, and the compounding was semi-annually, which it means N is 2. So I put these pieces into our formula. I have 7,000 times 1 plus 0.042 over 2 to the 2 times 2. I can plug this in my calculator, and it says at the end of 2 years, I have $7,606.78. This amount is very important because it's the starting part for our next piece. Our P is $7,606.78. So we don't go back to the 7,000, we go to where were we in 2 years. But our interest rate changed to 4.5%, our compounding changed to 12, and there are 3 years left of this investment. So I put these pieces into our formula. Up here, 12 times 3, you can see I made that 36. So this is what I want to put in my calculator. And again, I encourage you, go ahead and try it. Make sure you're also getting $8,704.04 as your total.